Assalamu alaikum. We are presenting our project Sorting Visualizer using C++ and STL2. This project visually demonstrates how different sorting algorithms work by animating bars on the screen and measuring sorting time. What the project does? Our program represents an array of integers as vertical bars where the height of each bar corresponds to the value. The bars are rendered in real time using STL graphics. When a sorting algorithm is selected through keyboard input, the array elements are compared and swapped step by step. Each step is visually shown on the screen. Different colors indicate comparisons, swaps, and completion. At the same time, the total execution time is printed on the console. This makes the internal working of sorting algorithms easy to observe and understand. Now I will tell you about the scope of the project. The scope of this project includes visualization of 6 classical sorting algorithms.
Now I will explain the project structure and how SDL graphics are handled. The project folder structure. Our project folder contains sortingvisualizer.cpp file, SDL2 folder, array file, executable files and other sample folders. And this structure is so that it keeps our project organized and modular. SDL initialization. SDL is initialized using different SDL functions, SDL init, SDL create window and SDL renderer. The window size is fixed at 910 by 750 pixels. Each array element is drawn using SDL rect function where x-axis position depends on the index and height depends on the array value. Visualization function. The core of our visualization is the visualize function. This function clears the screen every time, iterates through the array and draws each element as a vertical bar. Color coding was used by us. Green color for the active elements or swaps, purple for the current comparison, gray for the unsorted elements, and the light green for if the sorting is completed. SDL delay, that was the most important function used by us, which was intentionally added so that the fast algorithms like merge sort and quick sort can be visually followed. Array handling. The array is loaded from the array file.txt, otherwise randomly generated and saved back to the folder.
Assalamu alaikum. Now I will explain sorting algorithms and execution control. Sorting algorithms we have implemented. Our project implements 6 types of sorting algorithms. Selection sort selects minimum element in each pass. Insertion sort builds sorted portion gradually. Bubble sort repeatedly swaps adjacent elements. Merge sort divides and conquers with merging. Quick sort partition-based recursive sorting. Heap sort uses max heap for construction. Each algorithm is implemented as a separate function connected to the visualize function, modified with delays to show internal steps clearly. Our program is controlled through keyboard input. 0 to generate a new random array, 1 to 6 to execute specific sorting algorithms, Q to exit the program. The original array is restored. Time starts using standard chrono library. Sorting runs with visualization. Total execution time is printed on the console. Now I would like to tell you why our timing is important. Although visualization delay affect exact timing, the displayed results will still provide a relative performance comparison, clear difference between big O and square and big O and log n algorithms. Our project successfully combines data structures, algorithms, file handlings, and graphic programming into a single educational tool. Thank you for watching our sorting visualizer project. This project helps us understand sorting algorithms deeply by visualizing how they actually work under the hood and more than just memorizing the theory. I hope it has also helped you. Thank you.
Hello everyone, now we will give you a code walkthrough of our project. First of all, this is the basic folder organization of our project. These are all files which we have organized here. .vs code .samples. It contains the GIF which we have stored to for the visualization purposes. And further we have .txt file STL2 library which we are using for user interface and for the purpose of rendering window, readme.md readme file, and these are the 2 main CPP files which contain the basic logic of our code. Is sorting visualizer.cpp. It contains the main backend, and temp code runner, it is actually the code to run our project in using the console, and these 2 are executable files. Now let me open this sorting visualizer.cpp so we could better understand our code. So these are the libraries which we are using, and this program is implementing, as you know, visualizing using STL2 graphic library. At the beginning, standard C++ libraries are also included, while STL2 is being used for creating graphical window. And here you can see some global constants defined. These constants define the screen size, and these values determine how many bars are displayed and how they have been positioned. As you can see, here are two arrays that are declared. One array stores the current data being sorted, and second stores the original data, so it can be restored before running each sorting algorithm. Below it is STL initialization setup. The init function initializes STL video subsystem, and the close function properly destroys the rendered window. STL can ensure clean program termination and avoid memory leaks. The visualization is handled by visualize function. Down here you can see that the visualization is handled by visualize function, which is core graphical component of the project. The function clears the screen and redraws entire array on each frame. Each array element is represented using a vertical rectangle, while height corresponds to the value of that element. Different colors are used to represent different states of sorting. Green highlights elements being compared or swapped. Purple shows current comparison. And similarly, we have also used other colors. And one of the main functionality of a project is that you could choose the bar size by giving it an array input. So, and you could visualize sorting on any input. Now below we have implemented sorting algorithms. This is an array based implementation of all algorithms. Here it's selection sort, and you can see insertion sort, code for insertion sort, bubble sort algorithm, merge sort algorithm, and quick sort algorithm, heap sort algorithm. And this is load array function, which we are using to load array from the array.txt file, which is for example purposes we have stored in array.txt file, but we give the user an option to initialize a new array based upon user's input. Now I would like to tell you about how our execution flow is controlled. Our execution flow is controlled using keyboard input. The program listens for key presses to generate new array. Start a specifying sorting algorithm or quit program. When sorting algorithm starts, the timer begins using standard chrono library. The algorithm runs with visualization. All this is implemented in code here. When I would run the project, you would have better understanding that how this code is working. Now I would like to show you our program running. So this is a console based control or program, the console to control a program. As you can see, we have many options to choose from. We can generate a randomized list, or we can generate a array which would have corresponding bar sizes. We could run many algorithms from this list to see how those bars are being sorted to visualize. Actually, our program is an educational software which makes it easy for learner to comprehend and visualize the code and the algorithms which they are learning. So let me try and run it. So first, as you can see here, I have implemented selection sort over this list, and the algorithm is sorting the bars. Here is a sorted list. This algorithm is successfully sorted the list by visualizing, making it visualize it using the different sizes of bars. And here's the time, total time taken by this algorithm to run. Similarly, we can also run other types of sorts here on different bar sizes. Here this is insertion sort. Here is a sorted list. So here was walkthrough of our project. Thank you so much.